Hello everyone, welcome. My name is Muttadar Ahmad, and in this video I'll walk you through the JobTracker application that I have built. I'll demonstrate the main features of this app, show how it is structured, and briefly highlight some technical decisions about it. So, first of all, JobTracker was built to solve a common real-world issue that we have, which is managing multiple job applications across different companies and timelines. The main goal of this application was to develop a realistic job application tracker that focuses on clean architecture, scalability, and a good overall user experience, similar to what a person would see in a real-world production level app. About the tech stack, I have used React alongside TypeScript for the front end, Supabase for the back end, and also I have used React Query to handle remote state, Supabase to handle the authentication and the authorization for all data. Also, I have used Redux Toolkit for global UI state and also Tailwind for styling. I have used other technologies and libraries, and all are listed in the README file in the GitHub repo for this application. I will leave the links for you in the description. So, by the way, this application is hosted live, and you can go and try it out on your own, and feel free to do so. I would be very happy to receive any feedback from you. This is the main page that the user will be greeted with, and a user can sign in for an existing account or sign up for a new account. Just for convenience, since I want this video to be as short as possible, I will not create a new account and sign up, because this would take me through the email confirmation process, and this would take some time. Feel free to go and check it out on your own. I will use the demo access account that I have provided for pre-built data. This is the main dashboard for the job applications. Here a user can view their applications, they can delete any application they want, and they can also view a specific data about the application. So any application, of course, can be updated. We can update general info about the job application, and all changes are reflected instantly in the UI. This is handled through React Query, which keeps the client side state synchronized with the backend automatically. So for example, if we come back and we update this to what it was, it will be nearly instantly updated. And also here we have the ability to search for an application, for example Amazon. We can also filter based on the application status, let's say accepted, for example. We can also sort based on the company name, ascending, descending, and same applies for the job title, the status, and the date applied. And we can also do them all together, of course. This would not show any data, so let's just do it interviewing right here. And also, just to notice, if we leave this page and come back, all our filter options, search, and sort options will be already there without the need to write them again or just do them again. This is to keep the page as interactive as possible and for a better overall user experience. I will briefly mention how I implemented this feature when we go into the code. This is the stats page. Here is the visual breakdown of the applications, and also once again this is fully compatible with the applications itself. So if we update an application, if we add an application, remove an application, these for example pie chart and line chart would instantly be updated. And for example, my application also includes an AI-powered chatbot designed to enhance the user experience by providing guidance and instructions. The AI assistant here uses the ChatGPT API, with Supabase edge functions acting as a secure middleware layer. This allows the front end to make requests without ever exposing the ChatGPT API key, which is my API key. So this is for an overall better security. And here we can input any prompts, for example. And we can also use the already pre-built quick prompts to help us with the job applications. And yeah, that does it for this page, I guess. Here is the page for the user profile. Here you can view your own profile and info, and anyone can update the info for his own profile. By the way, this application uses authentication and authorization, so a user would only access the data regarding his own account, not the data regarding any other account. Here, for example, if we update this, once again, the data would be instantly changed in the UI thanks to React query. We can also update the user avatar, add a new skill, for example, and so on. Feel free to go and check it out on your own. So I think that does it for an overall quick overview of this application. And also we have the ability, of course, to add an application here and so on. I will leave the rest for you. And a quick look at the Supabase side. Here we have, for example, our tables. Here is the job application tables, the main table for the application. Here we have the info table. This table has my own info that is fetched in the footer of the app. Here I have, for example, my contact me link, which is my email, my portfolio link, my GitHub link, and all coming from here. I wanted to make it versatile and scalable so that if I change any link here, it would be already changed in the application. And I mentioned earlier that I have used an edge function, which is this function in particular. This function acts as the middleware between the front end, the API key, and the API for the ChatGPT API. Okay, I think that does it for the application here. Let's just take a quick look at the code. In the source folder, we have the components folder. Here are all the reusable components in the app. Here is, for example, the button component used across the app. Here we have the custom hooks. For example, each and every custom hook uses React query to fetch the data and store the data in the cache. For example, this custom hook uses this function coming from the services folder. We'll just show that briefly, and stores the job applications in the cache. So when we leave the page and we come back, we wouldn't see any loading spinners and we wouldn't experience any delays. Here are all the pages in this application, and this services folder is to maintain the separation of concerns. So all database interactions are centralized in a single layer, making the code base easier to maintain and extend. So this job applications API, for example, this file handles all the interactions between the client side and the server side when it comes to job applications. So this, for example, function is to upload an application. This function is to fetch applications from the Supabase database, and so on. The same goes for the user API, and this is the general connection between the client side and the Supabase server. Here we have the store folder. In this store folder, we have the slices for the Redux toolkit. For example, this slice handles the search, filter, and sort states. Remember how we said earlier on that if a user inputs some data here, for example, and applies a filter for the status, then leaves the page, comes back, the user should see the same data here and the same filters applied without the need to redo it again. I have implemented this using Redux Toolkit, and I could have implemented the same mechanism with a simpler technique, like for example a simple session storage would have done it, but I wanted to fully practice Redux Toolkit for a real-world application, and I have done this in this application. I have also implemented error handling and lazy loading and protected routes, but then again, all the info related to that and all the details are in the README, in the GitHub repo. So that was a general walkthrough of the JobTracker application. The live demo, the source code, and full documentation are available in the links in the description. Thank you so much for watching.